Hello everyone, I'm Tian. I'm very glad to introduce our project Santander product recommendation to you. This is for the cross Big Data Analytics at Columbia. As you can see, Santander Bank offers a variety of financial products, but now only a small number of customers can receive recommendations. So they need to expand the target customer for future recommendation, and they need more relevant and specific suggestions. This project is also a cargo competition, which has 1,700 teams to participate in. As for the technologies we use, we do data visualization, feature engineering, and we use logistic regression to compute feature importance. We use k-means as our first layer clustering, and we design recommendation algorithms. And above all, we use AWS Spark Cluster as our computation platform. We got the training set, the test set, and the sample submission file from Cargo. And we use this 1.5 year of customers' behavior data provided from Santander to predict what a customer will buy in addition to what they already had. So you can see that the customer's data is actually firstly grouped by time, and in each time slot, uh, every customer has an ID followed by all his profile and the product he owned. What can we do with this huge amount of data? And there are so many features, and how can we manipulate them? We think that data visualization is a very essential part of this project because it shows the logic behind this data, and it gives us a sense of intuition, which is very helpful when we decide what to do in later data processing. As you can see, this is a bar graph of monthly customer number and the popularity of products by income group, the graph of customer age and segmentation, the histogram of gross income of household by channel, and so on. So now we have better understanding about the data. We can do some feature engineering work. The first main problem we met is that a very important feature named the gross income of the household. It has the 24% of it is none. And to use that feature, we need to fill the none with other information. So we firstly find the correlation from all other feature to this feature, and we found that the activeness is highly related to that. And based on our visualization before, we also find that the income is distributed by city. So we firstly divide all the data into two parts, active and inactive. Then for each part, we group them by their province. And finally, in each small section, we filled the non-data with the median of the same section. Another main problem we met is that we have too many features. We have around 15 features, and it's highly possible that we will overfit at the end. So we decide to compute the feature importance for each product using logistic regression, and we create a data frame with rankings for each product and feature. Then we sum them up. to find the most important features overall. We pick up top 5 features as attributes for detailed processing. To get a good result of this kind of real-world problem, we think the key is that to design a specific algorithm according to the specific data set. So after our analysis of the data set, we divide the features into 2 parts. One is the custom profile, and another is a product they owned. The first part shows the similarity of customers in their background, and the second part shows the similarity in their behavior. We found it's not so easy to construct a direct reflection from background to behavior. So we decided to use the first part as the first layer clustering, and then use the second part to direct recommend the products to user. So we choose k-means. We do Spark k-means clustering to the first part of our data. Then we can get the corresponding clusters of the later part. Then for each cluster of product information, we do Spark collaborative filtering separately and get the final result. So what we really did is that we recommend the product to a specific user based on the behavior of people who have the same background. We did all the experiments in AWS because the dataset is too large and it takes a long time to run locally. And basically we have 2 parameters to tune. One is that we need to decide how many clusters we need to divide the dataset into. So we do experiment to decide the k in k-means. And another one is the ranking in collaborative filtering. The Spark collaborative filtering recommendation algorithm use the ALS method, which use some kind of matrix factorization method to do the recommendation. So we need to decide the number of dimensions of that latent matrix. And here's our sample output for each ID. We gave them 7 recommendations. Our evaluation used the mean average precision at 7, and here's our result. As you can see, we got about 0.028 precision at last, and in all of the 1,700 teams, we are ranked around 600. We think we get a reasonable result due to our hierarchical structure. First, we classify first, then recommendation use collaborative filtering. But we are also limited by the number of libs in Spark. We haven't fully implemented our design, and it would be better if we can use like XG boosting in Spark, which is very popular and efficient in Cargo. For more detailed information about our project, you can see our report. Thank you for your time.